everyone, welcome to Study Jam. In this video, we'll be going through Cambridge A-Level Pure Mathematics 1, question paper 12 of February-March 2022. If you enjoyed this video and found it helpful, please give a thumbs up and share it to your peers. If you'd like to receive updates on future videos, don't forget to hit the subscribe button as well as the notification bell. Alright, now question 1. A curve with equation y equals to f of x is such that f prime of x is 2x power negative 1 over 3 minus x power 1 over 3. It is given that f of a is 5. Find f of x. So we are given the gradient of the curve, which is f prime of x is 2x power negative 1 over 3 minus x power 1 over 3. So to get f of x, we can integrate the gradient. So f of x will be the integration of 2x power negative 1 over 3 minus x power 1 over 3. Integrating 2x power negative 1 over 3, we'll get 2x power 2 over 3, since we're adding 1 to the power. Then divide by the power, get 3 over 2. Minus integrating x power 1 over 3, we get x 4 over 3, and then divide by the power, we get 3 over 4, as well as a plus c, as we're not given any limits in this question. So simplify that. This is 3x power 2 over 3 minus 3 over 4x power 4 over 3 plus c. Now we can substitute in our f of 8 equals to 5. So our f of 8 will be 3, 8 power 2 over 3 minus 3 over 4, 8, 4 over 3 plus c. Our f of 8 is also 5, so 5 equals to this here, 3 over 8, our 2 over 3 will be 12 minus this here is 12 plus c. So our c will be 5. So rewrite back the equation. Our f of x will be 3x power 2 over 3 minus 3 over 4x power 4 over 3 plus 5. That is your f of x. Question 2. A curve has equation y equals to x squared plus 2cx plus 4, and a straight line has equation y equals to 4x plus c, where c is a constant. Find the set of values of c for which the curve and line intersect at two distinct points. So when we come across the word intersect or intersection, we can use the formula b squared minus 4ac. And since they intersect at two distinct points, b squared minus 4ac will be more than 0. So first step is equate your two given equations. So x squared plus 2cx plus 4 equals to 4x plus c. Now rearrange the equation so that one side will equal to 0. So x squared plus 2cx, then move 4x to the other side, minus 4x plus 4 minus c equals to 0. So combine these two like terms, so x squared plus bracket 2c minus 4x plus 4 minus c equals to 0. So now you have your a value, your b value, and your c value. So substitute these values into b squared minus 4ac. So we'll get 2c minus 4 squared minus 4, 1. There's an indivisible 1 at the front here. And our c, 4 minus c, more than 0. So expand and simplify. 4c squared minus 16c plus 16. Negative 4 times 4 minus 16 plus 4c more than 0. So negative 16 plus 16 is 0 for c squared, and then negative 16 plus 4c, this will be negative 12. 12c more than 0. So we'll then factorize this equation. So c will be, so 4c and c minus 3 more than 0. First, you need to find your two critical values. So your critical values will be 4c equals to 0 and c minus 3 equals to 0. So then you have c equals to 0 and c equals to 3. So when you have these critical values, you need to sketch them out on a reference graph, or what I call it, a reference graph. So your 0 and your 3. So since our b squared minus 4ac is more than 0, we want to find the area above the line here. So that means our c will be less than 0 or more than 3. Hence, our set of values for c will be c is less than 0 or c is more than 3. So these are our set of values for c. Question 3. Find the term independent of x in each of the following expansions. Part A, we are given the equation 3x plus 2 over x squared, bracket all of it to the power 6. So to find any term in a binomial expansion, the general formula will be NCR, or n choose r, times a power n minus r times b power r. In this case, our a is 3x and our b is 2 over x squared. So to find each term, our first term will be 6c0. Our n is 6, and the r for our first term will be 0, times 3x power 6 minus 0, which is 6, times 2 over x squared power 0, plus 6c1 times 3x power 6 minus 1 is 5, times 2 over x squared power 1, plus 6c2 times 3x power 6 minus 2 is 4, times 2 over x squared power 2. You can continue expanding until the last term, but for me, I'll just stop until the third term. Right, let's simplify each one. So 6c0 is 1. 3x power 6 is 729 x power 6. And any term to the power of 0 is 1. And 6c1 is 6. 3x power 5 will be 243 x power 5, and 2x times 2x, 2 over x squared. And then we have 6c2, which is 15, times 3x power 4, which will be 81x power 4. And we have 2 over x squared power 2, which will be 4 over x power 4. So this one, the first term will be just 729 x power 6. Our second term will be 6 times 243 times 2, 2916, and cancel out the x's, so this will be x power 3. X power 5 divided by x power 2 is x power 3. And then we have our third term, which is 15 times 81 times 4, 4860. And if you notice, these x's, x power 4 times 1 over x power 4 will be just 1. So this has no x. So 4860 will be our term independent of x. Part B. So we have an extra factor here, which is 1 minus x power 3. So since we don't have any power to this extra factor here, we don't need to do any binomial expansion. But we have two terms in here. So one is already independent of x, but not negative x power 3. So we need to find a term in this binomial so that when we multiply it with x power 3, we'll get a term independent of x. So it means that we're looking for a term in this expansion that is 1 over x power 3. Okay, so we can do trial and error to find a term that will have 1 over x power 3. So I'll take a guess. Let's see, let's try 3x power 3 times 2 over x squared power 3. So in front here will be 6c3. So if I simplify, 6c3 is 20. 3x power 3 will be 27x power 3. And 2 over x squared power 3 will be 8 over x power 6. Okay, so if we multiply x power 3 with x power 6, we will get a term that is over x power 3, as x power 3 divided by x power 6 is 1 over x power 3. So then we'll multiply the rest of the terms. So 20 times 27 times 8 will be 4320. All right, so rewrite the binomial like this. Our previous term independent of x was 4860, so you write that back. Plus 4320 over x power 3. You don't need to show the other terms. We're not interested in the other terms. So 1 minus x power 3. So 4860 times 1 will be 4860, and 4320 over x power 3 times negative x power 3 will get negative 4320. So 4860 minus 4320 will get 540. So this is your term independent of x in this expansion. Question 4. The first term of a geometric progression and the first term of an arithmetic progression are both equal to a. The third term of this geometric progression is equal to the second term of the arithmetic progression. The fifth term of the geometric progression is equal to the sixth term of the arithmetic progression. Given that the terms are all positive and not all equal, find the sum of the first 20 terms of the arithmetic progression in terms of A. Okay, that is a lot of info. Let's try to break it down one by one. Okay, so in this case, let's refer the terms in a geometric progression as UN, and the terms in arithmetic progression as TN, to not confuse ourselves. So the third term of a geometric progression, U3, is equal to the second term of an arithmetic progression, so that it will be equal to T2. So fifth term of a GP, U5, equals to sixth term of an AP, so T6. And the terms are not all equal, so the ratio cannot equal 1. And the terms are all positive, so the ratio is positive. So we need to find the sum of the first 20 terms of an arithmetic progression in terms of A. So that means our Sn. So in the formula sheet, we have the equation for our sum of arithmetic progression, which is Sn equals to n over 2 times 2a plus n minus 1 d. So we want the first 20 terms, which is S20 equals to 20 over 2a plus n minus, 20 minus 1 d. Since we want all of our terms to be in A, we need to find a substitution for the difference. So let's try use the information we have. So we have U3 equals to T2. So our third term of a geometric progression will be A power R, A times R, power of n minus 1. So 3 minus 1 is 2, equals to T2. So that will be A plus n minus 1 of the difference. So n minus 1, n minus 2 minus 1 will be 1. So this is A plus D. Our difference will be AR squared minus A. So this will be from our U3 equals to T2. And we also have our U5 equals to T6. So U5 will be A times R power 5 minus 1 is 4. And we have our T6, which is A plus n minus 1. So 6 minus 1 of the difference. So 5. Okay. So rearranging, we get the 5d equals to AR power 4 minus A. So this will be our equation 1. This will be our equation 2. So we can now substitute equation 1 into equation 2. So 5AR squared minus A equals to AR power 4 minus A. So expand 5AR squared minus 5A equals to AR power 4 minus A. So we can factorize out this A. So we get 5R squared minus 5 equals to AR power 4 minus A. Then we arrange the equation so that one side of it is equal to 0. So we can arrange it as AR power 4. Wait, sorry. Since we factorize out A, this is just R power 4 minus 1. So arranging it, we get R power 4 minus, sorry, that 5r. No, we can do this. R power 4 minus 5r squared minus 1 plus 5. Move the 5r and the 5 to this side of the equation. So r power 4 minus 5r squared minus 1 plus 5 equals to 0. So simplify it. R power 4 minus 5r squared plus 4 equals to 0. Now we can factorize the equation. So you can use your calculator for this. So we get r squared minus 4, r squared minus 1 is 0. So r squared equals to 4, r squared is equal to 1. So r squared equals to 1 is invalid since if you rearrange it, r equal to square root of 1, which will just be 1, and r cannot equal to 1 if you refer back to equation as the terms in the geometric progression are not all equal. So r cannot equal to 1. That means r squared will equal to 4. So now that you have your r squared, you can substitute this back into your first equation. So our difference will be r squared is 4, so 4a minus a. So our difference is 3a. So now you can substitute back this difference into our equation for the sum of the first 20 terms. So sum of first 20 terms will be 20 over 2 times 2a plus 20 minus 1, 3a. So 10 times 2a plus 19 times 3a. So 19 times 3a is 57. So plus 2a is 59a. So the sum of our first 20 terms in terms of a will be 598. Question 5, part A. Express 2x squared minus 8x plus 14 in the form of 2 bracket x minus a squared plus b. So in any quadratic expression, the general formula will be ax squared plus bx plus c. This question wants us to perfect the square for this equation. To perfect the square for any quadratic expression, it will be a bracket x minus b x plus b square, my bad, x plus b over 2 square minus b over 2 square plus c. So we need to first factorize out our a. So factorizing out 2 from this expression will give us 2 bracket x squared minus 4x plus 7. So next we need to transform or change our expression into this form. So our b is negative 4. So x minus x plus negative 4 over 2 square minus negative 4 over 2 square plus 7. So simplify. So x minus 2 square, negative 4 over 2, negative 2 square is 4, so negative 4 plus 7. So 2x minus 2 squared, 4 plus 7 is 3. And that is your expression. Part B. The functions f and g are defined by f of x is x squared for all real values of x, and gx is 2x squared minus 8x plus 14 for all real values of x. Describe fully a sequence of transformations that map the graph of y, f of x onto the graph of y, g of x, making clear the order in which the transformations are applied. All right. So first, if you realize that the function g of x is the same as the equation in the expression in the first part of the question, which is 2x minus 2 squared plus 3. So you can rewrite g of x as 2 bracket x minus 2 squared plus 3. So you can, by writing it this way, you can clearly see how f of x maps onto g of x. So first, the graph shifts in the direction of the x-axis and the y-axis. So in the x-axis, it shifts by 2 units to the right. Since it's negative 2 in the bracket, we go the opposite way. So a shift to a shift of 2 units to the right in the x direction. And then we have a shift of 3 units up in the y direction. That's not all though. Then we have the value of 2 here. The 2 multiplies to this whole function. So that means it's a stretch of factor 2. For good measure, I just put in the y direction. So that is your sequence of transformation. Question 6. The circle with equation x plus 1 square plus y minus 2 square equals to 85, and the straight line with equation y equals to 3x minus 20 are shown in the diagram. The line intersects the circle at A and B, and the center of the circle is at C, or A. Find by calculation the coordinates of A and B. So we are given the equation of the line and the equation of the circle. So to find the intersection points, which are A and B, we can substitute this equation of straight line into our equation of the circle. So we'll write it as x plus 1 square plus of y, we write 3x minus 20 minus 2 squared equals to 85. So we will get 8x plus 1 squared plus 3x minus 22 squared equals to 85. So we can expand both brackets. So we'll get x squared plus 2x plus 1 plus 9x squared negative 132x plus 22 squared is 484. And we move 85 to this side of the equation, so minus 85 equals to 0. So simplify, we'll get 10x squared to x minus 132. We'll get negative 130x, and this one will get plus 400 equals to 0. So we can simplify further this equation and factor out 10. We get x squared minus 13 plus 40 equals to 0. We can factorize this equation to get x minus 5 and x minus 8. Your x coordinates will be x 5 and x 8. To substitute back these values of x into our straight line equation, so when x is 5, y is 3 times 5 minus 20 is negative 5. And when x is 8, y is 3 times 8 minus 20, which will get 4. 3 times 8 is 24, minus 20, we get 4. So our coordinates of A and B will be 5, negative 5, and 8, 4. So these are your coordinates of A and B. Part B. Find an equation of the circle which has its center at C, and for which the line with equation y equals to 3x minus 20 is a tangent to the circle. So we can sketch this out to have a clear picture of how the new circle will look like. So our center is still at C. So the first part of the equation will still be the same. So it's still x plus 1 squared plus y minus 2 squared. But if you notice, we have our new circle will have a new radius. Since like in our original circle, when the line intersected at points A and B, it was a longer radius. And when the line was only a tangent intersecting at one point, it has a new shorter radius. And if you also notice, the midpoint of A and B will lie on this circle. So what we can do is we can find the midpoint of A and B and substitute it into our x and y to find our radius, or just our r square. So we can find midpoint AB from our coordinates that we got from the previous question. So our coordinates were 5, negative 5, and 8, 4. So our midpoint will be 5 plus 8 over 2, negative 5 plus 4 over 2. And we'll get 13 over 2 and negative 1 over 2. Substitute these values back into x and y. So our x is 13 over 2 plus 1 squared plus negative 1 over 2 minus 2 squared will equal to r squared. So just use your calculator to find this value, and our r squared will be 125 over 2. So our equation of the circle will be x plus 1 squared plus y minus 2 squared equals to 125 over 2. That will be your equation of circle. Question 7, part A. Show that sine theta plus 2 cos theta over cos theta minus 2 sine theta minus sine theta minus 2 cos theta over cos theta plus 2 sine theta is 4 over 5 cos squared theta minus 4. Man, that's a mouthful. Anyways, so first of all, we can make the denominators same with each other by cross multiplying. So we'll get sine theta plus 2 cos theta times the other denominator, cos theta plus 2 sine theta over cos theta minus 2 sine theta times cos theta plus 2 sine theta minus sine theta minus 2 cos theta and times this denominator, cos theta minus 2 sine theta over, so the denominators are now the same, so it will be cos theta minus 2 sine theta times cos theta plus 2 sine theta. Alright, so first let's simplify expand and simplify the numerators. So sine theta plus 2 cos theta and multiply with cos theta plus 2 sine theta, we'll get 2 sine squared theta plus 3 sine theta cos theta plus 2 cos theta over cos theta plus 2 sine theta cos theta plus 2 sine theta. I won't be solving the denominator first yet because to avoid any confusion. So let's solve this one now. So we'll get negative 2 sine squared theta plus 3 sine theta cos theta minus 2 cos squared theta over cos theta minus 2 sine theta cos theta plus 2 sine theta. So we can combine these two fractions to make them one whole big fraction. So we get 2 sine theta, sine squared theta, plus 3 sine theta cos theta plus 2 cos theta. Then expand. So negative and negative, so we get plus 2 sine squared theta. Negative positive, we get negative, so negative 3 sine theta cos theta. Negative and negative, positive, so plus 2 cos squared theta. And now we can solve for the denominator as well. So cos theta, so cos squared theta, we'll get cos squared theta, then minus 2 sine theta cos theta plus 2 sine theta cos theta minus 4 sine squared theta. So simplify both the denominator both the numerator and the denominator. So you get, for this one, these two cancel out. You get 4 sine square theta plus 4 cos square theta over cos square theta cancel out minus 4 sine square theta. Now in this stage, we can use the trigonometry identities. So sine square theta plus cos square theta is equal to 1. So we can factorize out 4. So 4 sine square theta plus 4 plus cos square theta. So this one will equal to 1. And we can use another trigonometry identity, which is sine square theta is equal to 1 minus cos square theta. So we can substitute the sine square theta with 1 minus cos square theta. So up here is the numerator is just 4, and you have your cos square theta minus 4 plus 4 cos square theta. And you'll get 4 over 5 cos square theta minus 4, which is your right hand side. Yep. So this will be your answer. Part B. Hence solve the equation for theta is between 0 to 180 degrees. So we can use the trigonometry identity that we solved in the previous part of the question. So this whole expression we can equate to this expression. So we can write it as 5 cos square theta minus 4 equals to 5. Then we can rearrange over here. So 4 equals to 5 cos square theta minus 4. So expand the equation. So 5 cos square theta minus 20 is equal to 4. So 25 cos square theta equals to 4 plus 20. And cos square theta is 24 over 25. So cos theta will be plus minus square root of 24 over 25. So we'll have cos theta is either positive square root of 24 over 25, or cos theta is negative square root of 24 over 25. So your theta will either be, okay, punch in the calculator, theta will be, the first angle will be 11.5 degrees, and your second angle will be 168.5 degrees. So your angle will lie in this, between here and here. So this will be your first angle, and this will be your second angle. So that will be your answer for question 7, part B. Question 8. The diagram shows the circle with equation x minus 2 bracket square plus y square equals to 8. The chord AB of the circle intersects the positive y-axis at A and is parallel to the x-axis. Part A. Find by calculation the coordinates of A and B. Right, we see here that coordinates A intersect at the y-axis, so the x-coordinates for A will be 0. So substituting that, we'll get 0 minus 2. So this is x-coordinate, y-coordinate of A. We'll get 0 minus 2 square plus y square equals to 8. So y square equals to 8 minus negative 2 squared will be 4. So 8 minus 4. Y will be the square root of 4. And it's a positive square root since A is above 0. So Y will be 2. So the chord AB is parallel to the x-axis, meaning the y-coordinates of B will equal to A, will be the same as A. So let's substitute back y into this equation. So x minus 2 squared will be equals to 8 minus y squared, which is 2 squared. So x minus 2 will be square root of positive negative square root of 8 minus 4. 8 minus 4 will be 4. So x will equal to positive 2 plus 2, or x will equal to negative 2 plus 2, which will give us x equals to 0 or x equals to 4. So earlier this was already the x coordinate for our A. So this must be the x coordinate for our B. Hence the coordinates of A will be 0, 2, this is A, and our coordinates for B will be 4 and 2. The y coordinates are the same. So these are your coordinates for your respective points. Part B. Find the volume of revolution when the shaded segment bounded by the circle and the chord AB is rotated through 360 degrees about the x-axis. So we want the volume of revolution for this particular segment. So what we can do is find the volume of revolution for this part of the circle, and then minus it from the volume of revolution by this triangle. So first, we're going to find volume of revolution for the circle. So for volume of revolution, we find it by pi integrating y squared dx, since we're rotating it about the x-axis. So we have our equation x minus 2 squared plus y squared equals to 8. So our y squared will be 8 minus x minus 2 square. So that will give us pi integrate 8 minus 8 minus 2 square dx. And our limits are 4 to 0. This was our b coordinate and our a coordinate. So integrating will give us 8x minus x minus 2 power 3 divide by 3. This is 1 over 3. 4, 0. We don't have a plus c since we have our limits given. So that will be pi 8x minus 1 over 3 x minus 2 cubed 4 to 0. So first we have 8, 4 minus 1 over 3, 4 minus 2 cubed minus 8, 0 minus 1 over 3, 0 minus 2 cubed. So for this value, we'll get 32 minus 8 over 3 minus 8 times 0 is 0. Then we have negative 2 cubed is negative 8. So negative 8 times negative 1 over 3 is positive 8 over 3. And then times the negative, we get a negative 8 over 3. To simplify each term, 32 minus 8 over 3 minus 8 over 3 we'll get 80 over 3 pi. Right. That is our volume of revolution for our circle. Next, we need our volume of revolution for our rectangle, but it's just basically like our cylinder. So this will be our radius, which is your y coordinate, and your height is the x coordinate of B minus the x coordinate of A. So your volume of revolution of your rectangle, or basically your cylinder, will be just pi r square h, where your r is 2, which is your y coordinate, and your h will be 4 minus 0, which is 4. So your volume will be pi 2 square 4, and you'll get 16 pi. So your volume of revolution for your shaded segment will be 80 over 3 pi minus 16 pi. And you'll get 32 over 3 pi. That's your answer for question 8, part B. Question 9. Functions f, g, and h are defined as follows. F of x is x minus 4x power half plus 1 for x is more than 0. G of x equals to mx squared plus n for x is more than or equal to 2, where m and n are constants. And h of x is x power half minus 2, for x is more than or equal to 0. Part A. Solve the equation f of x equals to 0, giving your solutions in the form of x equals to a plus b cert c, where a, b, and c are integers. So we're given our f of x, which is x minus 4x power half plus 1, and we want to solve it for 0. So we can use the quadratic formula to solve this equation. So our quadratic formula is x equals to negative b plus minus square root of b squared minus 4ac over 2a. So in this equation, our a value is 1, our b value is negative 4, and our c value is 1. So instead of x, we'll put x power half as the subject, and we will substitute in our a, b, and c values here. It's not the same as the a, b, c values here. It's just for this quadratic formula. So our negative b will be 4 plus minus negative 4 squared minus 4ac. Our a is 1, our c is 1. And then divide by 2a. So 2, 1. So our x power half will be, okay, using your calculator, you'll get 4 plus minus 12 over 2. And simplifying it, you'll get 2 plus minus 3. So our x power half is either 2 minus 3 or 2 plus 3. And our x will be when we move this power half here, you'll get 2 minus 3 squared, or x equals to 2 plus 3 squared. So solve for this. First, you'll get 4 minus 4 3 minus 3, which gives you 1 minus 4 3. And if you solve for this part, you'll get 4 plus 4 3 plus 3. Oh, sorry, this is plus 3. So you get 7 minus 4 3. And then here you'll get 7 plus 4 3. Answer will be x is minus 4 3, or x is 7 plus 4 3. That's your final answer. Part B. Given that f of x is the same as g h of x, find the values of m and n. So our f of x was x minus 4x power half plus 1. Our g of x was mx squared plus n, and our h of x was x power half minus 2. So gh of x will be m x power half minus 2 squared plus n. So expand and simplify. We get m bracket x Expand here, you'll get x minus 4, x power half plus 4 plus n. So it gives you mx minus 4mx power half plus 4m plus n. So the question says that f of x is the same as gh of x. So you'll just do a comparison between gh of x and f of x. So if you see that the equation looks similar to f of x, so our mx is equal to x, our m will just be 1. And our 4m plus n will equal to 1, because it's the same here, and here. So rearrange, n will equal to 1 minus 4m, and our m is 1, so 1 minus 4 times 1. So n will be negative 3. So m is 1 and our n is negative 3. Question 10. The diagram shows a circle with center A of radius 5 cm and a circle with center B of radius 8 cm. The circle touches at the point C so that ACB is a straight line. The tangent at point D on the smaller circle intersects the larger circle at E and passes through B. Find the perimeter of the shaded region. So the perimeters or the lengths of the shaded region will be DC, DE, and EC. So DC is an arc of circle A, and EC will be an arc of circle B. So let's try find the find the length of DC first. So length of an arc is the arc length will equal to r theta. So we have our radius, which is 5. So we need our theta. So you can find the angle by using SOHCAHTOA. So this length here will be 5, as it's the radius of a circle A. And this whole length here is 13. So we can use, so this length of 13 is the hypotenuse of the triangle. And the length, the AD is adjacent to the angle. So we can use formula cos theta equals to 5 over 5 plus 8. So theta will be our cosine 5 over 13, which will give us 1.176 radians. In the formula r theta, our theta will need to be in radians. So length of DC will be 5 times 1.176, which will give us 5.88 centimeters. Second is to find length of EC. So I need to find this angle here. So we can find this angle by using the sine formula. So sine, so to find length EC, first we need to find theta. So we can use this formula, sine theta equals to 5 over 13. So theta will be arc sine 5 over 13. So that will be 0.3948. I'll use for significant figures. So length EC, continue up here. So length EC will be the radius times the angle. So our radius will be 8, which is the radius of circle B. So 8 times 0.3948. This will give us 3.158. Now we need to find length of DE. So you can find length DE by finding DB, the whole length of DB, and then minus it off with length our radius of circle B. So this is DB, and then we minus it off with our radius. So we can find DB by using the Pythagoras theorem. So DB square will be 13 square minus 5 square. So let's give us 144. So dB will be the square root of 144, which is 12. So that's our dB. So now we can find dE by minusing off the radius of circle B. So dE is 12 minus 8, which is 4. So the perimeter of shaded region will be 5.88 centimeters plus 3.158 centimeters plus 4 centimeters. And you'll get 13.004 centimeters. Actually, it's better to give it as 13.0 centimeters because we give our answers in 3 significant figures. So 13.0 centimeters. So that will be your answer for the perimeter of shaded region. Part B. Find the area of the shaded region. So earlier in our diagram, we had an outline of a triangle and 2 sectors. So when you sketch this out, it'll look like this. So you can find the area of the shaded region by first finding the area of triangle and then minus it with the area of the sector in circle A. We'll call this area sector A. And also minus it with the area of the sector in circle B. We'll call this area sector B. So first we'll find our area of triangle. We already have our base, which is 12, and our height, which is 5, where we found it in the previous question. So our area of triangle is half times 5 times 12. This is 30 centimeters squared. And then our area of sector A will be half r squared theta. Our r for sector A is 5, and our theta, which we found in the previous question, will be angle DAB, 1.176 radians. So our area for sector A will be half 5 square 1.176, and we'll get 14.70 centimeters square. So for area of sector B, it will be the same, half r squared theta, where our r is 8, and our theta will be angle DBA, which we found also in the previous question. So area sector B is half times 8 square times 0.3948, and we'll get 12.63. It's better to give 4 or 5 significant figures where you can before you round up to the final answer. So our area of shaded region will be 30 minus 14.70 minus 12.63. This gives us 2.67 centimeters square. So that is your area of shaded region. Question 11. It's given that a curve has equation y equals to k bracket 3x minus k power negative 1 plus 3x, where k is a constant. Part A, find in terms of k the values of x at which there is a stationary point. So to find the values of x where there is a stationary point, dy dx must equal to 0. So first we need to differentiate y. So dy dx will equal to k times negative 1 times 3, which is the differentiation inside the bracket, times 3x minus k power negative 1 minus 1, which is negative 2. And differentiating 3x will give us 3. So our dy dx will be negative 3k times 3x minus k power negative 2 plus 3. So since our dy dx is 0, negative 3k 3x minus k power negative 2 plus 3 will equal to 0. I'll rewrite this part of the equation as a fraction. So negative 3k over 3x minus k squared plus 3 equals to 0. Then I'll get rid of the fraction by multiplying the whole equation with the value of the denominator, which is 3x minus k squared. So I'll get negative 3k plus 3 bracket 3x minus k squared equals to 0. Then I'll move the 3k to the other side of the equation, giving me 3 times 3x minus k squared equals to 3k. We can factorize out the 3, leaving us with 3x minus k squared equals to k. The 3x minus k will either be positive or negative square root of k. So rearranging to give x will give us k plus minus square root of k over 3. So these will be your values of x at your stationary point in terms of k, which is either k plus square root of k over 3 or k minus square root of k over 3. Part B, the function f has a stationary value at x equals to a and is defined by f of x equals to 4 times 3x minus 4 power negative 1 plus 3x, for x is more than or equal to 3 over 2. Find the value of a and determine the nature of the stationary point. So first, we need to find the stationary point for this function. So if you realize f of x is similar to our earlier equation, which is y equals to k times 3x minus k power negative 1 plus 3x. So by comparison, our k for f of x is 4. So our values of x earlier at the stationary point were x equal to k plus square root of k over 3, or x is k minus square root of k over 3. Since our value of k in this function is 4, we can substitute back the value into our stationary point. So x will be 4 plus square root of 4 over 3, or x will be 4 plus 4 minus square root of 4 over 3. So this gives us 2 and 2 over 3. So for the value of a, it is more than 3 over 2. So hence x equals to 2 over 3 is invalid. So our value of a will be 2. Now to find the nature of the stationary value, we'll need to differentiate further our dy dx. So earlier our dy dx was negative 3k 3x minus k power negative 2 plus 3. So our dy dx for a function of f for f of x is negative 3 times 4 is negative 12, bracket 3x minus 4 power negative 2 plus 3. So we can differentiate this further, giving us d square y dx squared, which is negative 12 times negative 2 times 3, which is the differentiation inside the bracket. Then we write back the function inside the bracket, which is 3x minus 4 to the power negative 3 minus 1 from the power. This will give us 72 3x minus 4 power negative 2. And then substitute back the value of a into our d square y over dx squared. We will get 72 times 2 minus 4 power negative 3 will have a 9. So as our d square y dx squared is more than 0, our point will be a minimum. Hence our value of a is 2, which is a minimum value. That will be your answer for part B. Part C. The function g is defined by g of x equals to negative 3x plus 1 power negative 1 plus 3x, for x is more than or equal to 0. Determine, making your reasoning clear, whether g is an increasing function, a decreasing function, or neither. So doing again another comparison with the earlier equation, which is y equals to k, 3x minus k power negative 1 plus 3x. Our k for a function g of x is negative 1. To find out whether it's an increasing function, a decreasing function, or neither, we can determine it by seeing if our gradient is always positive, always negative, or neither. So first we need to differentiate for g of x. So if our dy dx was negative 3k, 3x minus k power negative 2 plus 3, the dy dx for our g of x will be, substituting back k negative 1, will be 3, 3x plus 1 squared plus 3. So I'll write this back as a fraction. 3, 3x plus 1 squared plus 3. So the only like term here having an x is the denominator. And because our denominator is squared, so no matter what value of x you have, it will always be positive or more than 0. Hence, our g prime of x, or dy dx, will always be more than 0. Our conclusion can be gx is an increasing function as g of x, or our dy dx, is always positive. Because since your gradient is always positive, always increasing, so your g of x will be an increasing function. That is your answer for part C. Thank you so much for watching this video. If you found it helpful, please share it with other people so they may also benefit from it. If you'd like to give any feedback or like to ask for any specific paper to be solved, you can leave a comment in the comment box below. Again, thank you so much and see you in the next video.